Well, welcome. My name is Mr. Murphy, and I am going to be teaching you this lesson 6.5, which is all about properties of logarithms. And we're going to be looking at, just like it sounds, a number of different properties that you're going to want to know to be able to work with logarithms. So it's really important that you understand these concepts. So to start out with, though, let's start with a math joke. What do organic mathematicians throw into their fireplaces? Natural logs. Sorry. Bad joke. Anyhow, here's what we're going to be looking at today. So we're going to be looking at properties of logarithms, how to expand logarithms, and how to simplify logarithms. So before we get started, though, instead of doing a warm-up today, I want you to see if you can't make a connection here. So we have this log of x is graphed below here, or off to the side here. And on that graph, like we said, there's 3 points. And I want you to look for a relationship between the numbers 3, 5, and 15. Now, there may not be a direct relationship between just the 3 and the 5, but as a whole, I want you to look at a relationship between just the 3, 5, and 15. And then I want you to look at a connection between the y values, the 0.477, the 0.699, and the 1.176. Now, there may not be a connection that you can make right away, but I want you to just think about that for a minute. So pause the video and see if you can make a connection between those. And then even the x's and the y's. You should be able to at least make a connection with the x's. All right. What did you come up with? Hopefully we're able to discover that, well, 3 times 5 is 15. Now, maybe you tried some different things with the y's. Maybe you took 0.477 times 0.699. And if you multiply those together, you do not get 1.176. But did you try adding them? If not, try adding them. And if you add those together, you would see that 0.477 plus 0.699 is 1.176. Interesting. So when we multiply the 3 times 5 and get 15, the result is that the impact that has for the y values is that we would add those values to get to 1.176. Well, what do you think that means for getting the log of 45? So using that information, can we come up with a log of 45? Well, how might we do that? Well, 3 times 15 is 45. So maybe adding the 0.477 plus 1.76 would give us the log of 45. Or log is 75. How could we get 75? Well, I recognize that 5 times 15 is 75. So maybe adding together the 0.699 and the 1.176 would give us log of 75. Which is actually what happens, which is what brings us to those properties. So here we have the 3 properties. So I've highlighted this page, so I'm going to try to do a good job of making sure to pinpoint when you need to get this information, the information that you absolutely need to have in your notes. And this would be one of those things. You absolutely want to have these properties. And I would recommend having the names of them. Now, we're not going to say, what's the property of logarithm, or what's the product property of logarithms? You're just going to have to know how to use this. And when I say we're going to do this forward and backwards, meaning that going from the left to the right, or from the right to the left. What do I mean by that? Well, if we have the log base b of m times n, what we just found in this warm-up or in that discovery thing that we just did on the previous slide is that we could find the log base b of m times n by adding the values. Log base b of m plus log base b of n. That's what we did there. We added those y values. When we knew that 5 times 3 is 15, to find the answer, we could take the y values and add those together. That's a product that's the product property of logarithms. The quotient, that's a little harder to see on just discovering it on our own. But the quotient theorem says that if we have log base m divided by n, it's equivalent to the log base b of m minus log base b of n. Let's make a connection there. Because if you think about it, multiplication and division are opposites of each other. Well, if log base b of m times n is equal to log base b of m plus log base b of n, well, then if division is the opposite of multiplication, then the opposite must also be true, that we would subtract these. Now, the order that we subtract things is important. So you want to take the numerator, log base b of m, minus the denominator, log base b of n. Now, like I said earlier, we want to be able to do these forwards and backwards because there are going to be times where we would have something written as log base b of m plus log base b of n, like Okay, doing abstract things sometimes isn't the easiest. Let's say if I have log of 5 plus log of 7. We want to know how to be able to combine those as a single logarithm. So that's a situation where we'd go from right to the left. Okay, and we'll get to examples like that later. Now the last property there that I want to talk about is this one. Now it might be hard to see what's going on there. Now what's happening here is this exponent. If you ever have an exponent, sometimes we'll need to simplify that by putting that exponent in front of the logarithm. So that's what's happening there. That n has been moved to be in front of the logarithm. Or vice versa. If we already have a number in front of the logarithm, sometimes it's useful to recognize that that number that's in front of the logarithm would be an exponent for the value of our logarithm, the log base, whatever m is. Okay. So let's look at some actual examples, because when we see things like this where they're just in general terms, it's hard to make sense of it. So again, I want you to write these in your notes, even though it's not highlighted there. Hopefully you understand that examples, you would definitely want to get those in your notes. But write down, so pause the video and write down these two examples. Log base 5 of the quantity a squared b to the 7th, and the natural log of the quantity 25 divided by 3. So copy those down, and then, so pause the video, copy those down, and then we're going to go over those together. All right, let's look at that first one. So the first thing we're going to do is we're going to apply that product property of logarithms. So remember what that means is that we're going to pull this apart as two separate logarithms. Now it's important. It's not this, do not write log base 5 of a squared plus b to the 7th. No, we're pulling these apart as two logarithms. So it'll be log base 5 of a squared plus log base 5 of b to the 7th. Including that second log base 5 is part of that property. So you want to make sure that you do that exactly as the property says. All right, so the next thing we're going to do after, so again, pause the video if you need to write that down. But the next thing we're going to do is we're going to apply that power property of logarithms, that last property, because if you recognize both of those values, the a and the b, have exponents. And so we could take those exponents and move them. But we're going to move them in front of the logarithm. Not in front of the parentheses, in front of the logarithm. So that would be 2 times the log base 5 of a plus 7 base log, or plus 7 times log base 5 of b. And that would be your answer. Okay, there's nothing that we have to do beyond that. All right, let's look at the next one. So the next one, natural log of 25 divided by 3. So again, the first thing we're going to do is we're going to write the numerator as a power. So this is the, so this isn't anything that we did in the previous one. I want to change these though, because I recognize that 25 is the same as 5 squared. Okay, so that's not one of those properties that we just talked about. That's just recognizing that, 25 is the same as 5 squared. Is that going to be useful? And it will be. We want to make sure that we always have things, if we're working with numbers, that if they can be squared or cubed or raised to the 4th power, that we put them in that form. Write them as powers when possible. All right, so now we're going to use, the next thing, we're going to use a quotient property of logarithms. That's the second one that we saw in the previous slide. And so we're going to break these apart as subtraction. Again, it's the natural log of 5 squared minus the natural log of 3. We want to include the natural logs in there. Again, I recognize that I have an exponent there for the 5, so I'm going to move that exponent in front using that power property of logarithms. So our final answer would be 2 times the natural log of 5 minus the natural log of 3. So in essence, that's how we use those properties. I want you guys to try some on your own. Now, both of these are a little tricky where we use a lot of different properties. And I gave you a hint in that second one, because 225 is not just any single number raised to an exponent. So what I did is I just said that 225 is the same as 9 times 25. Okay, so those are two what we call perfect squares that we'd multiply together. Okay, so I want you to use that hint to help you out with that second one. Okay, so I want you to pause the video. Please do as much of this as possible. Okay, it's okay if you make mistakes. It's okay if you don't quite know or feel confident with 100% because you're just learning this. But I do want you to try this. Don't just wait for me to explain it. I want you to try this on your own. So go ahead, pause the video, and then try these, see how far you can get, and then hit play when you're ready to check to see how you did. All right, let's look at this, both of these, but let's focus right now on the left. So the first thing we're going to do is what's in red there. So we're going to pull that apart, and you don't have to write down what property it is each time, but we're going to pull that apart. So we'd have the log base 7 of r cubed t to the 4th minus log base 7 of v. Now I recognize that in that first parentheses, we're multiplying those two values. So if I was just given that piece alone, I would want to recognize that I would want to pull that apart too, but since we're multiplying, when we pull that apart, we would write it as two separate logarithms being added together. So it'd be the log base 7 of r cubed plus log base 7 of t to the fourth, and then minus log base 7 of v. And now I recognize that a couple of those terms have exponents, and so we're going to take those exponents and put those in front of the logarithm. So we would have 3 times log base 7 of r plus 4 of log base 7 of t minus log base 7 of v. So that would be your final answer. There's nothing more we can simplify there. All right, let's look at the second example there. So that one, again, I gave you that hint that 225 is the same as 9 times 25. Well, hopefully you recognize that 9 is 3 squared and 25 is 5 squared. So now we're going to pull those apart. What's in blue there? We're going to pull that apart to be the natural log minus the natural log of 7 minus the natural log of 3 squared times 5 squared. All right, so to see more of this, I'm going to have to make myself transparent. All right, so now you can see the rest of this. Okay, so we have the natural log of 7 minus, we're going to take that 3 squared times 5 squared, and we're going to pull that apart again, just like we did in the previous one, to be the natural log of 3 squared plus the natural log of 5 squared. But do you notice what I did there? Because we're subtracting that entire piece, the natural log, going back a step, what's in blue there? We're subtracting that entire piece, the natural log of 3 squared times 5 squared. So when I pull that apart, I want to make sure that I'm not just subtracting the first term, I'm subtracting everything. So that's why I put that in parentheses. And then I distributed that minus through. So it'd be minus the natural log of 3 squared and also minus the natural log of 5 squared. All right, so again, I always look to see, is there anything more that we can do? I notice that we have exponents there, so I'm going to put those exponents out in front. So it would be natural log of 7 minus 2 times the natural log of 3 minus 2 times the natural log of 5. And that would be your final answer. All right, now you can see me again. And let's look at this next example. So in the next example, now we're going to go the opposite direction. Remember I said that at the very beginning when we saw those properties. Sometimes we do it from left to right with those properties, with the left side of the equation and then going to the right side of the equation. This time we're going to go from the right side to the left side, meaning we already have these broken apart. And we want to combine these and write these as a single logarithm. All right, so we're basically going to do the opposite of what we were doing before. So the first step, so the last step was always to look to see if there's any exponents. We move those in front. So here we're going to do it backwards. And so I'm going to start by looking to see, do we have any numbers in front of the logarithms that we would put as exponents for the values? And clearly we do. So that's going to be the first thing we do here. So we would take and use that power property of logarithms. So we're going to take that 4 and that 3, and we're going to apply those as exponents for the m and the n. All right, now we're going to start combining some of those properties. So first thing I recognize is that product properties. We have m to the 4th plus n cubed, or log base 4 of m to the 4th plus log base 4 of n cubed. So those two we can combine using multiplication. So we would have the log base 4 of the single m to the 4th times n cubed. But then we have minus the log base 4 of p. So remember, that means that we're going to divide that p, that quantity. So we're going to write this as a single logarithm. Again, there should only be log written down once if we're writing it as a single logarithm. Okay, if you have log base 4 of m to the 4th n cubed divided by log base 4 of p, that's wrong, because you have two logarithms. You want to make sure it's a single logarithm. So we're applying those properties to put this all together to get this all as a single logarithm. Because you should be able to work your way backwards. When you get your final answer for these, you should be able to look up and be like in the previous examples that we did where we pulled it all apart and be able to get the same answer that you had originally. Okay, let's look at the next one. Here we have 3 times the natural log of 2 minus 2 times the natural log of 5. Again, remember, we look for exponents first. So those exponents would be represented as numbers in front of the logarithms, or in this case, the natural logarithms. So the 3 would be an exponent for the 2. The 2 would be an exponent for the 5. So we'd have natural log of 2 cubed minus natural log of 5 squared. And now we would write that as, again, combine that as a single logarithm. So we would have natural log of 2 cubed divided by 5 squared, okay, as a single logarithm. And the last thing we're going to do is simplify. And to be honest, if you wanted to even simplify previously and have natural log of 8 minus natural log of 25, and then write as a single logarithm, that you would get the same answer, natural log of 8 divided by 25. So that's how you write it as a single logarithm. So I want you guys to try some on your own. Personally, I think these are actually a little bit easier. So why don't you guys go ahead and try letters A and B. So again, pause the video, do as much of this as you can on your own, and then hit play when you're ready to check to see if you've done it correctly. All right, how did you do? Let's see. So starting with that first one, so again, we look to see, are there any exponents? And the 5 and the 7 would both be exponents for the c and the n. So we'd have log base 2 of c to the 5th minus log base 2 of n to the 7th. And since we're subtracting, to write this as a single logarithm, we would divide those values, c to the 5th divided by n to the 7th. So your answer would be log base 2 of c to the 5 divided by n to the 7th. Okay, looking at letter B there. Again, we only have a single exponent there. The 2 would be an exponent for the 7. So we'd have the natural log of 7 squared plus the natural log of 2. And then we could combine those as a single logarithm. So we'd have the natural log of 7 squared times 2. And 7 squared is 49. And 49 times 2 would be 98. So to simplify that, we'd have the natural log of 98. So that's how you would do those. All right. That's it for today's video, because we're going to get to the, so that's all you need to do for today. So go ahead and hopefully that made sense to you. And if not, make sure you get those questions answered. So in that way you know what to do in your assignment.